Alright, today's video is about graphing compound inequalities. So our objective is going to be students will be able to graph compound inequalities. We've talked about how to graph a single inequality, like x is less than 4, so we would draw out our graph. We draw an open dot at 4, and we shade to the left. Now we're going to talk about how to draw a graph a compound inequality. So compound inequality is going to be something like 3 is less than x, and x is greater than 4. It's going to be two inequalities in one. Alright, so let's do an example. So we're talking first about compound inequalities that contain the word and. So the graph of a compound inequality with and is going to be the intersection of the graphs of the two separate pieces. The intersection of the graphs of the two separate pieces. The solution must be a solution to both of the inequalities. So we're looking for a place where the two graphs intersect so that the solution works for both of the inequalities. So let's go ahead and do an example. So we have graph the solution set of x is less than 3 and x is greater than or equal to negative 2. Notice we see the word and, so we know that this, whatever our solution is, it's going to have to work for both of the inequalities. So I'm going to go ahead and graph the first inequality. X is less than 3. I'm going to draw an open dot on 3, and I'm going to shade less than 3. My second graph is x is greater than or equal to negative 2. So I'm going to draw a closed dot on negative 2, and I'm going to shade to the right. Now I'm looking for the place where these two graphs intersect. So what I'm going to do right now is I'm going to draw a little line for myself that crosses at our dots. The dots are usually the boundaries of our solution set. Notice that these two graphs cross here. This is going to be our solution. So I'm going to copy down my closed dot at negative 2 for the greater than or equal to, my open dot at 3, my line got a little bit off, my open dot at 3 for the less than or equal to, and my solution is going to be where they cross in the middle, so I'm going to shade the middle. This is my solution, and let's talk about why that solution works. Now, any number we pick inside here should satisfy both of these inequalities. So let's recopy down x is less than 3, and x is greater than or equal to negative 2. And let's see if we pick a number in here, will it work? Let's pick a number like 1. Is 1 less than 3? Yes. Is 1 greater than or equal to negative 2? Yes, 1 is greater than or equal to negative 2. That works. So this is a solution. Let's pick a number outside. Let's pick a number like 6. Is 6 less than 3? No, this is not true. 6 is not less than 3. Is 6 greater than or equal to negative 2? Yes, that does work. Now notice, this one works, but this one doesn't. In order for it to be a solution, both need to work. This works because both were a solution. This is going to be no solution because one of them does not work. We also should talk really quickly about these dots. Now, is negative 2 going to be a solution? The answer to that is yes. It's a closed dot, so it includes negative 2. Is this open dot going to be a solution? No. It's not a solution because it's an open dot and does not include 3. The last thing I want to show you is that sometimes and inequalities are going to be written as a compound and not separate. And we'll talk about that in a second. And so you might see something like x is greater than or equal to negative 2, but then they might combine this over here. So they might, instead of writing an x again, they're going to write this part over here. So my v needs to open to a 3, so it's going to look like this. You might see compound inequalities like this, and we're going to have a couple of examples that are like this. If it looks like this, I want you to just go ahead and rewrite them. So this would be x is less than 3, and x is greater than or equal to negative 2, so you can go ahead and rewrite. I also want you to practice writing your compound inequalities like this because it will be a good practice for reconverting them. Alright, let's go ahead and do another example. We have graph the solution set of -1 is less than x, and x is less than 6. I'm going to go ahead and rewrite this one so the x is on the left. It's going to be x is greater than -1. I'm going to graph that one first. X is greater than -1. So I'm going to draw an open circle on -1, and I'm going to shade to the right because it's greater than. I have x is less than 6, so I'm going to draw an open circle on 6, and I'm going to shade to the right, left, because it's less than. Now, a big common mistake that a lot of students make is that they won't draw their arrow very long, and so they'll think, oh, the two graphs cross right here. But remember, this arrow I just drew a little bit short, but it's going to extend all the way over here if it wanted to. So the place where these two graphs intersect is going to be the boundaries of where your dots are. So draw your lines down from -1 and +6. They're going to cross here. So I'm going to copy down my boundaries, or my dots. I'll draw an open circle at -1 and an open circle at 6. And where these two graphs cross is the middle. This is where they intersect. Now let's check a couple of numbers and see if they're solutions. The solution should be a number in the middle. So if I have x is greater than -1 and x is less than 6, let's pick a number like 3. Is 3 greater than -1? Yes. Is 3 less than 6? Yes. Both of my solutions work, so this is a solution to the compound inequality. Remember, you need both to work. Would -1 be a solution? No, it's an open dot. It's not going to be included. Would 6 be a solution? No, it's an open dot. It would not be included. Any number that lies outside is also not a solution. Let's rewrite this really quickly as a compound inequality. So I'm going to put the x in the middle. I know that x is going to be less than 6. And this one's already kind of prepared for us, but x is going to be greater than -1. So I need to, if I read from the variable, I need to have the greater than by the x, -1. Alright, I want you to go ahead and pause the video and try these two practice problems. I want you to not only graph, but I also want you to check one of your solutions and also write as a compound inequality. So what I mean by a compound inequality is write your inequality like this and try to write it like that and check your answer. Alright, here are the solutions. We should have had this portion of our graph shaded. 1.5 would be a solution, but 6 would not, and our compound inequality would look like this. This is our solution to the second problem. 0 would be a solution, but 5 would not, and our graph should be the shaded middle part. And here's our compound inequality. I want you to go ahead and pause the video again and try these 4 problems. Now notice here, these two are our compound inequalities. So before you graph these, I would take them and separate them out. So this is saying x is less than or equal to 0. So x is less than or equal to 0. I just read from this side over. This one says x is less than 3. This one says x is less than 3. So go ahead and graph those. This one is going to say z is less than 2.5. z is less than 2.5. This one says z is less than or equal to 9. So in order to graph these ones, separate them out. Go ahead and pause the video and try these 4 practice problems. Alright, here are the solutions to the practice problems. I want to do these ones with you because they're a little bit tricky. So we had x is less than or equal to 0 and x is less than 3. So we should have put a closed dot on the 0. A closed dot on the 0. And then we should have put an open dot on the 3. They're both less than, so they're both going to be shaded this way. Now remember, you're doing this on one graph, and it's a little bit harder to do it on one graph. But you're only going to get one graph when you're taking your Explorer, your interim. So we need to try to do it on one graph. If you graph 0 as less than, you're going to shade over here. If you graph less than 3, you're going to shade over here. Now, the only place that these two graphs cross is right here. They do not cross here. And because it's an and inequality, a compound inequality is written like this, we only graph the part that they cross. So we would only graph the closed dot for 0 and everything to the left of it. This one's very similar. We have z is less than 2.5 and z is less than or equal to 9. So I'm going to draw a closed dot on 9, and I would shade everything to the left. I'm going to draw a closed dot on an open dot on 2.5, which then I'd also graph to the left. This one would be graphed to the left. This one would also be graphed to the left. But the only part that they cross is right here. So we would only graph the part that they cross. Alright, now we're going to talk about how to write a compound inequality from a graph. Now, you've kind of been practicing this because you've been practicing compound inequalities, but right now I'm going to give you some really clear directions. The first thing that you should just do is draw an X in the middle. Just draw an X. The second thing that you should do is draw your two numbers. So I have a -10 and a 4. Next, we need to decide on the inequality sign. So let's do -10 first. This is a open circle, so I know it's going to be a less than symbol. I'm sorry, I know it's or a greater than symbol, and it's not going to include the equal to. And if for these to cross, this one had to be greater. It had to be shaded this way, so I'm going to draw a greater than symbol without the equal. I know this is going to include the equal to because it's a closed dot. In order for this one to be shaded this way and cross here, it would have to be a less than. If we want to write these two, we have to write X is greater than our -10, and we need to put the word and, X is less than or equal to 4. We know it's and because they cross here, they intersect. We also should practice writing it as a compound inequality. So I want you to put an X in the middle. We're going to put -10 on one side and 4 on the other. Now we're just going to copy down our inequality signs, reading from the X. So X is less than or equal to -4. This says X is greater than -10. So I'm going to draw the V to open to the X, so that X is greater than -10. X is greater than -10. It works reading both ways. So this is the first way we could write our compound inequality. This is the second way you could write your compound inequality. If you write it this way, the word and needs to be in between. So let's do this one again. I'm going to draw two X's, X and X. Let's do this one first. We have a -9 and a 5. So I know that this is not going to include the equal to because it's not filled in, and it needed to be a greater than. So X is greater than -9, and this one needed to be a less than. X is less than 5. Let's also rewrite this as a compound inequality. This is the first way. This is the second way. So I know that one of my numbers is going to be -9 and the other one's going to be 5. So this is going to be X is less than 5. This says X is greater than -9. So I need to write it the other way. X is greater than -9. And there are two ways to write our compound inequalities. I want you to go ahead, pause the video, and try these 5 practice problems. Make sure you write it both ways. So one of them should have X something and X something. The other one should be written as a compound inequality. So X with your two inequality signs and numbers on either side. Alright, here are the solutions. Go ahead and check your solutions, and then when you're ready, you can pause the video, check your solutions, and then when you're ready, press play, and you can see the rest of the video. Alright, so now we're going to talk about graphing compound inequalities containing the word or. Now this is going to be slightly different. The graph of a compound inequality with the word or is going to be the union of the two graphs. The solution is a solution to one of the inequalities. So the difference is in an and inequality, they had to work for both of the inequalities. In an or inequality, it only has to work for one. So let's do a couple of examples. So it says, graph the solution set of a is greater than 4 or a is less than or equal to negative 2. So since it's an or, it only has to work for one, at least one. At least one. So graph the first inequality. So I'm going to graph a is greater than or equal to 4. So I'm going to draw a closed dot, and it's greater than, so I'm going to shade to the right. And then my second one is a is less than or equal to negative 2. So I'm going to draw a closed dot at negative 2. And it's less than, so I'm going to shade to the right. Now you'll notice these two graphs will never cross. That's okay. They're just going to go in opposite directions. So I'm going to redraw a is less than or equal to negative 2. And I'm going to redraw 4 is greater than or equal to, a is greater than or equal to 4. This is how I graph an or inequality. Now remember, our solution only needs to work for one, so let's see if it works. A is greater than or equal to 4, or a is going to be less than or equal to negative 2. Let's pick a number here. Let's see if negative 5 works. Is negative 5 greater than or equal to 4? Is negative 5 greater than or equal to 4? No, that does not work. Is negative 5 less than or equal to negative 2? Yes, that's true. Negative 5 is less than negative 2. Now, this is a solution, and the reason why is that this is an or inequality. If it's an or inequality, the solution needs to work for one, at least one. So it cannot work for one, and it could work for the other. If we picked a number over here, it would also work. So let's pick a number like 6. Is 6 greater than or equal to 4? Yes. Is 6 less than or equal to negative 2? No, that's false, but this is a solution because it works for one of the inequalities because it is an or statement. Now, any number that falls outside will not work. So let's pick a number like 1. Is 1 greater than or equal to 4? Is 1 greater than or equal to 4? That's false. No. Is 1 less than or equal to negative 2? No. These numbers don't work because they both fall outside of either of the inequalities, so this is not a solution. Now, when we did and inequalities, we wrote it as a compound inequality with x in the middle. Or inequalities will not be written like that. We're always going to write them separate. Let's do one more example. Graph the solution set of x is less than 0 or x is less than 5. So remember, this means that we need to have at least one works. So let's do this first. X is less than 0. So I'm going to draw an open circle at 0. And I'm going to shade to my left because it's less than. I'm going to draw an open circle at 5. And shade to my right because it's greater than. This is an or statement, so they're not necessarily going to cross, but my solution is going to be one that works for both. So I'm going to redraw both of my graphs. Any number here will be a solution. Any number here will be a solution. So let's just pick one really quickly to check. X is less than 0, and we have x is less than 5. All right. So let's pick a number like negative 3. Let's see if that would work. Is negative 3 less than 0? Yes. Is negative 3 less than 5? Yes. Uh-oh. We must have done something wrong. And this is why it's really important for you to check your answer. Because this is an or statement, so it should only work for one of them. If you are doing an or statement and you see that it works for both, I'll go back and check your work. So let's go ahead and let's go back and check our work. So I'm looking at this and I'm going to make sure, did I graph both of my equations correctly? Did I graph both of my equations correctly? So let's look back at x is less than 0. Well, I drew an open circle at 0. That works. And then I drew less than that. Good. That works. All right. Now let's look at the second one. X is less than 5. Okay, I drew an open circle at 5. That's correct. I did that part correct. and it says x is less than 5, did I draw or did I shade anything less? No, I actually drew greater than. So if I would have just moved on, I would have gotten this wrong. That's why it's really, really important that we're checking our solutions. We should have had an open circle at 5, and it said less than, so we should have shaded to the left. So what we can do is adjust our graph a little bit. And let's erase this, and we'll start over. Remember that these are going to overlap, right? Now, it's okay that these overlap. It's an OR statement, meaning that as long as it works for one, it works for both. We are actually going to shade a lot of this graph. We're going to draw an open circle at 5, and then we're going to shade everything over here to the left. Everything over here to the left. Now, if the number falls here, it'll work as a solution. If the number falls over here, it'll work as a solution. Alright, so I want you to go ahead and try these 4 practice problems. Now, these 2 are like the last example we did, so keep that in mind. On these last 2, I want you to rewrite them because we won't normally see compound inequalities like this, so I want you to cross this out. And I want you to just rewrite the 2 inequalities like this. Go ahead and pause the video, try these 4 practice, and then press play when you're ready. Alright, here are the solutions. Go ahead and check that you did them correctly. Check that you have the right dots, and also check that you have everything going in the right direction. We're going to talk about one more thing, and that's writing compound inequalities from the graph. Now we're going to do this very similar to how we wrote the AND compound inequalities. We know this is going to be an OR because it's going in either direction. So I'm going to go ahead and write OR in the middle, and I'm going to have X and X. One of my numbers is going to be -6. One of them is going to be -1. I've got to find my signs. So I'm going in the less than direction, and there's no equal to, so X is less than -6. This one's going in the greater than direction, and there is a filled in dot, so I know it's going to be greater than or equal to. You do not need to write this as a compound inequality. For OR statements, there's only one way to write it, and this is it. Sorry, we're having some video malfunctions. Here are your 4 practice problems. Sorry, we skipped around a bunch. Go ahead and try these 4 practice problems. Press pause, and then when you're ready, press play, and you can see the rest of the video. Alright, here are your solutions. Go ahead and check your solutions, write down any questions that you have, and be ready to practice in class.